So today we're going to be finding how to calculate the line integral of this vector field from two points in the field. So basically, first what we're going to have to do is check if this vector field is conservative. So first I'm going to denote all of these. So this is df over dx, which is equal to m, we'll say, we call this m. This is equal to df over dy equal to n, and this is df over dz, which is equal to p. So to test if it is conservative, we have to check if three equations are true. So we're going to have to check if the partial derivative of n with respect to y is equal to partial derivative of n with respect to x. Partial derivative of m with respect to z is equal to partial derivative of p with respect to x, and partial derivative of n with respect to z is equal to partial derivative of p with respect to y. So we're going to check all of these. So first, our m here, so the partial derivative of this in terms of y here, that's going to be equal to, well, this one it won't really matter because there's no y term in it, so that just becomes 0 when you take the partial derivative, and this one this one will just, the partial derivative of this term with respect to y will become 6x, so this is equal to 6x, and then with respect to x, the second term here won't matter as there's no x, and this will become 6x as well. So this is true, they're both equal. With respect to dn over dz, this term won't matter, so this one will just be partial derivative of this, so that's going to be 8z, so 8z, and this one with respect to x, sorry, this should be, I believe, an 8xz, right, xl, so this is going to be 8x because, sorry, 8z, yeah, because the x will just become 1 when it's differentiated. And then the n in terms of z, there is no z term in it, so this becomes 0. And in the same case, there is no y term in p, so this becomes 0. So all of these are true, so we can say that this field is conservative. And basically what it's saying is that the line integral, if you go from any, because you can like take multiple points on the vector field, you can go like this to here, you can go like that, you go just straight like that. It's basically saying like the line integral, I believe, is the same is equal for all of them. So because this is conservative, we can go to our next thing. So we're going to have to find the scalar potential function. So we know that df over dx equals 6xy plus 4z squared. So what we're going to do to find f, which is what we're going to want in the end, is we're going to take the integral with respect to dx on both sides. So this will just become f, and this is equal, well, with dx here, this is going to become 3x squared y, and this one becomes 4xz squared. And then it's usually when you do an integral like this, indefinite integral, it's going to be c, like a constant, and this, it's not actually c here, it's actually, because there's three variables, it's a function of the other two variables, y and z. Now what we're going to do is we're going to differentiate this function in terms of y, the partial derivative of this in terms of y. So this is just going to get you 3x squared. This is just going to become 0, so we can just x that out. This one becomes c, y, z, and the derivative of that in terms of y. So we have our df over dy here is equal to 3x squared. plus 3y. So these two should be equal considering they're the same thing. So that's basically saying that the derivative of this dy is equal to 3y squared. Alright. So what we're going to do next is we're going to take this one in terms of z. So it's going to become df over dz is equal, this becomes 0. So it becomes 8xz. And then this becomes cyz dc over dz. So it looks like in terms of this case, this is just 8xz. So this, if we set this equal to 8xz, that means that this is just not true. So, this is just equal to 0. So because there is the partial derivative of that in terms of z is 0, that means that there is no z term in our function c of y of z. So it just becomes c of y. So now we can just say that the derivative in terms of y of dy is equal to 3y squared, and because now we can just integrate on both sides in terms of dy, we know that our c of y is equal to 6y plus, now we can just say regular c. So now we have this field right here. So remember, we just made this into cy. So, and we have our cy down there. So f is equal to 3x squared y plus 4xz squared plus 6y. Oh, sorry, I took the derivative here. This should be y to the third. Y to the third plus c. So now we have to solve. So we found our scalar potential function, but now we have to solve this. So this is actually now pretty simple. All we would have to do is we have to do the f of 1 minus the f of 0, 0, 1 to solve this. And now because we use f as our scalar potential function, as we know. So this is just gonna, and by the way, we can just treat this c as 0 in this case, so we can really ignore that. Of course, there may be situations where you have to like calculate for c value, but here we can just treat that as 0. So we're gonna say that 3 times 1 squared times 2 plus 4 times 1 squared plus 2 to the third minus, well, this just becomes 0. This will just become 0 as well. And this one also becomes 0, so this is just 0. So whatever this is equal to, so this is, let's see, that's 1 squared, right? So this is equal to 6 plus 4 plus 8, and that is equal to 18. So that is the answer to our line integral. Thank you for watching.